Hey there students, it's Mr. Sharp again here for the first video in our 5th unit for Technology, Engineering, and Design. I know I've got a new background behind me, but hopefully that won't interfere or mess with your mind as we move forward today. We're going to be talking about energy and power today. This is going to be starting a series of topics that we now focus on how the engineering design process works in the real world, also known as the design world. We focus a lot on energy and power because this is what helps keeps the lights on in our home. This is what keeps the power going throughout cities, and this is what helps us maintain this infrastructure that we have all across the world. So when we talk about energy, we have to focus on the smallest details. Let's use your body as an example. Your body is a source of energy because we have different muscles that allows us to perform work. This is the reason why we use energy to create or perform work. One example is if I have a heavy box in front of me and I need to push it from one side to the other, my body is using energy to push that box, outputting the work, and my body needs fuel in order for it to create that energy. We know that we have to have a big breakfast in the morning, so that food, which generates calories in your body, that what we burn allows us to convert that energy from the calories into the work that we're going to output. Unfortunately, the human body has a very limited capability. I can't lift 400, 500 pounds over my head, even though I wish I could. So we have to use other different processes and machines in order for us to go beyond human capabilities. And like I said before, how we convert calories into work, that's going to bring us to one scientific law that we have to understand before moving into energy and power. This is called the first law of thermodynamics. If you've ever taken a physics class before, you may have heard this, but in the simplest terms, energy cannot just be created out of thin air, nor can it be destroyed. It can be converted from one form into another. That's a basic concept, that it can be converted equally from one form into the other. And we have to be able to harness different methods and processes in order to create energy that is beneficial to us performing that work. There are different types of energy sources that we work with in the industry, and they include thermal energy, which is also a form of using heat or joules as a form of energy, light or radiant energy, using the sun's rays, those UV rays that are bouncing off from the atmosphere, electrical energy, using electrical power from a current that allows us to harness that within conductors. We also rely upon mechanical energy. This is from simple machines like gears, levers, and pulley systems that we've talked about before in Unit 3. Chemical energy, using different types of chemicals, like using calories as an example, using gasoline in your car as an example of chemical energy. And then lastly, nuclear. How do we use fusion from different atoms to create a huge amount of heat energy that allows us to harness that? We've talked about that before in Unit 2, even though it has some bad results. Nuclear energy is actually a very clean form of energy if it's done correctly. So, moving on from there, in this unit, we're going to be talking about the different aspects of these energy sources and how they're incorporated into different sources and how we harness that. We also need to understand that as we convert these forms of energy, whether it be nuclear or chemical, some at the end in the output may have negative consequences, some may have better consequences than others. For example, we have to identify the outputs into two different types of fields. Those include renewable and non-renewable energy sources. So when we talk about renewable, we're talking about sources of energy that is abundant, that will never run out as much as we use it. So the non-renewable sources of energy can include radiant energy from solar panels, thermal energy, which is generated from underneath the heat, underneath the ground, from geothermal energy, and also maybe wind power, which is a form of mechanical engineering or energy. So these are sources that will never run out. This is generated by nature, and we can harness it. However, sometimes The bad consequences of this, the output may not be as effective as other means for producing energy. So we rely upon other sources, which is the major part of our energy industry today. However, in the modern age, we have seen negative consequences per that form of creating that energy. Those include these non-renewable forms of energy, which also means that the source of this energy may run out. It's not abundant. These include fossil fuels, the burning of coal and gasoline, which is a form of chemical energy. I'm trying to mix up my words for energy and engineering at the same time. Can't be doing that. But these forms of gasoline and oil, burning that at a certain point to create a thermal energy to create motion is not renewable. In addition to that, it may have negative consequences of its output. Or uranium, nuclear energy, that is a source from our table of elements that is not abundant. It will run out. So we have to find a good median between these two forms of energy in order for us to make sure that we as a species will never run out, but also that we are protecting those sources that we have right now and producing enough energy that will last for the huge population that we do have. So to wrap up in summary, we discussed the first law of thermodynamics, how energy cannot be created or destroyed. It's only converted from one form to the other. We talked about 6 different forms of energy. And then lastly, we discussed the difference between renewable and non-renewable energy sources. As we move forward in this course, we'll have to see how these different elements put together in order for us to create a process or design that allows us to convert one source of energy, convert it into other forms so we can create work. With that, I hope you guys have a good day, and I'll see you guys for the next video. We talk about manufacturing and material science. Have a good one.